How will trusted computing change operating system boot? Imagine starting your computer and knowing that every step of its startup is verified and trusted. That's the promise of trusted computing and its impact on how operating systems begin their work. When you turn on your device, the hardware kicks things off with a tiny piece of code called the core root of trust for measurement. This code measures the firmware, whether it's BIOS or UEFI, by creating a cryptographic hash. It then sends this hash to a special hardware chip called the Trusted Platform Module, or TPM. The TPM stores these hashes securely in its platform configuration registers, which are like secure vaults for trust measurements. As the boot process continues, each component, the bootloader, the operating system kernel, and critical startup files, are measured and verified before they run. These measurements are chained together, meaning each stage depends on the previous one being authentic. If any part has been tampered with or altered maliciously, the cryptographic hashes won't match what's stored in the TPM. This mismatch triggers security measures that can stop the boot entirely or prevent untrusted software from loading. In systems like Windows, Trusted Boot works alongside Secure Boot, which checks the digital signatures of the kernel and drivers. If something isn't signed correctly or has been changed, the system refuses to start or attempts to repair itself. Linux systems also use trusted boot techniques, employing the TPM and measured boot methods to verify the integrity of boot components and the kernel. The main benefit of trusted computing is a much higher level of security. It guards against malware that tries to load before the operating system, such as rootkits or bootkits, which traditional antivirus software might miss. It also gives users and administrators confidence that the system only runs trusted software, which is especially important in sensitive environments like government agencies, enterprise servers, or embedded systems. Trusted computing changes the way the operating system starts by creating a hardware backchain of trust that begins with the earliest hardware instructions. This chain continues through the firmware, bootloader, and into the operating system itself. It makes sure that only genuine authorized code is executed during startup. This approach significantly reduces the risk of persistent malware or unauthorized modifications taking hold at the very start of the system's operation. In essence, trusted computing makes the boot process more secure and reliable. It ensures that your device begins its day with a verified and trusted foundation, giving you peace of mind that your system is safe from the moment it powers on.